Hi guys, I want to show you today on how to use Geogebra software to demonstrate reflection along the X, the Y, and even the line Y equals to, that's Y and X axis, and the line Y equals to X, Y equals to negative X, um, as they are here. That is the X-axis reflection, the Y-axis, the Y equals to X, and the Y equals to negative X. For instance, this is the figure as it is with these coordinates. This is a triangle with coordinate, this point coordinates 82, the point 84, the point 42. You can shift or move these coordinates by using these points here, by using these sliders here. These are sliders. You just move the sliders, they remove the points. For instance, if I move this slider, you can change the points of that triangle. You can, if I move that way, it has changed. Yeah, so you can do that and move to wherever you want it to be. Move to wherever you want it to be. For instance, mine, I want it to be at the point where it was. At that point, because to enable me to show you the reflection in an easy way. For instance, now if I want to reflect this through the x-axis, this is the x-axis, I say that show reflection along the x-axis. So this is the x-axis, and this is what happens. The distance from this point, you just measure up to this point, they are equal. If this was point A, and then this is A prime. If this was point A2, A prime will be 8, negative 2. If this was point B, 8, 4, B prime will be 8, negative 4. So you can show the distances. If I show the distances here, you're able to see that the distance from here, this along the y, it is 2. Because if you minus 4 and 2, you get the length is 2 centimeters. Because mostly one big box here is equivalent to 2 centimeters, to 1 centimeter, so this is 2 centimeters. So, and this is also 2 centimeters from here to here, because you move along the y here axis. So, we can also see, you are able to see that from here now to here, the length will be, this is 2 plus 1, it is around 3 centimeters. So we have, those are the lengths. So this is how reflection is. If you are using a pair of compasses in the Cartesian plane, remember you just drop a perpendicular from here through the x-axis, then you just prolong, then you measure the distance from here to the mirror line, and from the mirror line, because the x-axis now is the line of symmetry, we call it the line of symmetry or the mirror line. So you can also measure now from the mirror line to the other point, it should be equal, the distance should be equal. So if I show along the y-axis, this is the y-axis, so we shall reflect the drop of perpendicular from here through this y-axis and measure the same distance. Just measure from here to here and from here to the other point through the y-axis. You shall be equal. If I show, this is how it will be. So it will become, you can see there is something you are noticing, that if you reflect through the y-axis, if you reflect it through the x-axis, the value of x does not change, but the y's change to negatives. If it was positive, it changed to negative. If it was negative, it will change to positive. But through the the y-axis, there is something you notice is that the value of y is not changing. If, for instance, 84, it is only the x which changes, and x changes in the sense that if it was positive, it becomes negative. If it was negative, it becomes positive. Like now, the coordinate, if it's 84, then the coordinate here becomes negative 84 through the y-axis. But and if it was 82, then because y will not change, will remain 2, then the 8 becomes negative 8. But if it was negative 8 and 2, then the y should be positive now 82. So that is about the reflection on the y-axis. The value of y does not change. If it's y-axis, the value of y does not change. For x-axis, the value of x does not change. The other one changes by changing the sign. It's negated. So that is on the y-axis. The reflection along the line, the distances, if I want to show, you can show the distances. That is how the measurements of distance are. From here, if you count 1, 2, 3, 4, these are another 4, so that is a length of 8 centimeter. And this one is also 1, 2, and the 2 here is 4 centimeter. You can see it is 4 centimeter. So that is it. But from here to here is 1, 2, 3, 4, 5, 6. It will be 6 centimeter. So that is it. Then you can also reflect through the line y equals to x. The line y equals to x is the line that passes through the origin this way. So if I show it here, that is the line y equals to x. You have to label as the line y equals to x. And the reflection of this point, remember we are not reflecting this one, we are reflecting the original object through the line y equals to x. There is something you can notice about the coordinates. The coordinates, there's something you are noticing about them, that if it is through the line y equals to x, then if it was AB, then the image becomes BA, meaning what? The value of x becomes the value of y, and the value of y becomes the value of x. Like if it is 4, 2, if it is 4, 2, then the image will be 2, 4. 4, 2, the image will be 2, 4. That is when it's reflected on the line y equals to x. If it is 8, 2, the image becomes 2, 8. The image becomes 2, 8 when it is reflected on the line y equals to x. If it is 8, 4, the image becomes 4, 8. So you can realize that is another way of just doing it without construction. Remember, if you are doing on a Cartesian plane, you need to construct. Like you just drop a perpendicular from here through this, drop a perpendicular from here through this. But you can easily show it in an exam situation that if it is the line y equals to x, then you can easily say that 8, 4, you put an arrow equals to 4, 8. Simple as that. If you are talking about point 82 becomes equals to 2, 8. Simple as that. So that is reflection on the line y equals to x. Then you can show, if you wanted to show the lines, because if you are constructing, you need to have dropped the perpendicular through this point, and then you measure the distance from here to here, becomes the same distance from here to here. As simple as that. Then we can do it another reflection of this original object through the on the line y equals to negative x. Line y equals to negative x will pass through this point. So this is it. This is the line y equals to negative x, and sure you label it. So you can see the object comes here. There's something you can notice also through that. If it's the point, this was point 42, 42 becomes 24, but both of them negated. So the y becomes the x, but negated. Negated meaning if it's positive, it becomes negative. If negative becomes positive, both of them. And if it is 8, 2, it will be 2, 8, but both of them negated. It will be 2, 8, both of them negated, meaning negative 2, negative 8. If it is 8, 4, it will become negative 4, negative 8. So that is the reflection on the y equals to negative x. You can show that in an exam, just say like 8, 4 becomes negative 4, negative 8, and then you draw those lines. If you show on first of all calculation showing how they will be reflected, then you draw them, then without construction is okay. But still, if you construct, it is still okay. So that is, I can show you in the distances also, so that you see this is a very simple way of demonstrating reflection using Geogebra software. I hope it has benefited you, and then you can go ahead and click the bell there. You like this video, and you also subscribe if you haven't. Thank you for listening.